Alright, this is a video for Lab 5 and we are going to talk about assembly and drafting. Okay, so first we're going to introduce two types of the assembly design. Then we will show you how to add components into an assembly file and how to position them within this file. And then later on it will be how to modify an individual component within the assembly, as well as how to display only one part of the assembly. Then the last will be how to make a drafting out of your assembly file. Alright, so let's take a look at the assembly first. So we have this assembly here, and this is one project we did before. So you have a couple of different parts, okay, and you can put them in the same file. And if you notice here, the assembly has exactly the same file type as modeling file, which is .prt. So you have to be very careful about the assembly file. If we go to the folder of this this model, you really can't tell which one is the assembly, because they're all part file in Windows. So when you create your assembly file, you might want to name this with some words that you can remember. Okay. Alright, and you can also tell that from NX here it says modeling, and actually we are doing assembly. So I don't know how they created this program, but modeling and assembly, they're very close. And the only thing you can tell is from here, if you uncheck this assembly toolbar, okay, you notice this assembly toolbar is gone, and still you can operate this assembly file. So no big difference. Just remember to name it well. Okay, now there are two types of assembly design approach, top down and bottom up. You can Google them, and usually we just use bottom up. That means from the smaller parts to the higher level, the assembly. So the bottom is your parts sub-assembly, then we go up to your the final assembly. Then top down is basically you say I want a machine that can do this, that function, and based on the function and your requirement, you would say, okay, I want this part to have this claw here that will be able to grab something. Then later on you design the claw based on your function. So that's two different approaches. And alright, now start assembly. Okay, since we have those two open already, then we can build a new one. So create a new file again, and here in this course we still use inch, and you can pick assembly. Okay, as you can see, the file name is exactly the same as the modeling, and then you can save it to some place you know. Okay, and when you rename your assembly, you would want to make sure you know that that's your assembly. So I'm gonna rename this with some words indicating this is an assembly, then I'll save this. So that will be the first dialog box you will see when you create a new assembly. Here is the parts that's loaded. I have something here because we have two assembly open. So if you just start from scratch, nothing is loaded, no parts is loaded, you would see nothing here. And so in that case, you want to open some parts. Okay, so you can find the parts from here, open your folder. Then in this Windows Explorer, you can go for computer, find your parts anywhere. Then you can load your parts. Go for the old one. Let's say I want to load this part, right? Okay. And keep in mind that you cannot have the same name of the parts. So maybe this one. Alright. Now this is a new part we just loaded. It's not anywhere here, but it's loaded in the program. So you would be able to add them. Then you can pick from the loaded parts and you can insert into your assembly. And when you place your parts, you have a couple options. So first is absolute origin. So basically it will put this origin of your part right on top of the origin of your assembly. Then you can use by constraint. If you have a part here already and you want to put this hole on top of another hole aligned with another cylindrical face, you can use by constraint. And you can use move. It'll probably show you a dynamic coordinate system. You can drag it around. Okay, so choose whichever you like. And for here, reference set, usually we just put this on model, unless for the part you have some different reference set. That is usually for a very big assembly that you have like simplified geometry in another reference set. So, but you can also change this later. So don't have to worry about this, especially in this course. You can just say OK. Now that's your first component. Alright, now this is assembly navigator. You can see your component. You can clear this checkbox to hide the component. Okay, so that's the one of the methods to add components to your assembly. Then that's about the reference set. Then okay, second way to add components. Okay, so if you have already inserted some components and you want to add more, here is your command, add component. If you can't find it, just use command finder, type in the name and it will show you where this is, or it's deep down in the menu. I think, let's see where that is. Assemblies, components. You can add a component. You can also have another or other options, okay, like create component array. If you have the same structure for like 10 the same structure, you can create component arrays. Okay. Alright, so what about we add another component? And keep in mind that this is assembly. However, you can also insert another assembly, which is called subassembly. Okay. So for this particular model, we do have a subassembly here, subassembly wheel. Let's go to the completed model here. Okay, so for this dolly, you see you have three identical structures. So we can, when we make this assembly, you can make this wheel assembly first. Make this one sub-assembly like this. Okay, and so you don't have to insert 3 times for the same components, which is here. So many components here, right? And of course, you can insert another sub-assembly under this level too. So it really depends on your application. And let's go back to this demonstration. So we can insert parts or subassembly. Let's find the subassembly. here, and we can also try use different placement. Let's say by constraint. Right. So by constraint, this wheel subassembly is aligned on this hole through a rivets. So we can use constraint here. If you click OK, it will show this assembly constraint window, and it will ask you for what constraint you want to put between those two parts. So we will choose fit here. We will talk about this constraint later. So fit is it will align two cylindrical face with the same diameter. So you pick those two and you click OK. See how this is aligned. Those two cylindrical face, they are aligned in the center axis, and that's how you can insert a component, or the component which can be parts, or which can be also can be subassembly, and we can use different positioning options. Alright, now next we will introduce the assembly constraints. So that's by using constraints, we can put the components at the ideal position relative to each other. So like the fit we just used. Well, let's add a constraint, which is here, assembly constraints. And in this window, you can see there are a lot different constraints. And if you're familiar with a geometric constraint in modeling, in a sketch, you probably will understand this fairly easily. So they both have fixed constraint, then you have concentric and the parallel, etc., etc., and you can try them out. And so let's introduce some of the useful ones. So touch align. Okay, let's go for the first one. Touch align is it will make two faces touch. That's simple. And it's not necessarily a flat face like this. It could be a cylindrical face to a flat face. Okay, let's move this first. So if you want to move the whole assembly, subassembly, you can click on that. There's a move component, and you have your dynamic coordinate system here. You can move 6 degrees of freedoms. Translation, and that's rotation. Okay, you can just rotation. It tells me there's a constraint within this assembly, within this subassembly. So you can pick the whole thing. Right click, move. Okay, and now you can drag it like this. That's the rotational degree of freedom. Then you can also drag it on translational direction. Note how this big piece is also moving with the subassembly, because we had this fit constraint here. So it will guarantee the cylindrical faces aligned with each other. However, if you move on the axial direction, there's no power. The constraint doesn't have any effect on the axial direction, because even now they're still aligned. Okay, so that's how you move a component, and we can keep introducing the touch aligned constraint. So let's move this lower a little bit and try to flip it. Okay, it doesn't let me do that. Alright, so what I'm going to do is actually fix this first. because now all the parts are floating in space. So you want some anchor point. And one thing to evoke the assembly constraint command is simply click on the part and you have this pop-up menu. You can pick some command for this part. And I'll use fixed constraint for this. So now this component is fixed. We can put this, delete this constraint first. And since this is actually reverse direction, so I'm gonna reverse this 180 degrees. Okay, then put constraint back on the fit constraint for the cylindrical faces, and it must be with the same radius or diameter. Okay, now they're coaxial now. However, it should be underneath this, where the touch align constraint coming. So touch align, and there's some sub options you can choose here. You can like align touch, okay, or you can just use the preferred touch, which is kind of a smart tool. So select the two objects. I'll select this top surface, the topmost surface of this subassembly. Then select the bottom flat surface of this dolly body. And once you click, you see the subassembly just jumped to the correct position. And now let's try to move this subassembly. Okay, Z direction, nothing happens because we have this touch align constraint. X and Y is constrained by the fit constraint. So the only degree of freedom you can move is actually Z rotation, which matches the real world situation, right? So that's pretty good for this component. And you have angle. Let's say I don't want this wheel to freely rotate. Okay, then we can add a constraint, and you can try angle. Okay, then you have the option to pick different type of angles. So 3D angle, that's fine, and you should find something that's like a straight line or something. And I know this one was a straight line. Okay, and let's pick x-axis, which we don't have really. What about this face? Okay, there's really nothing that straight I can pick. Let's try to put a datum system here. Okay, now we have something we can pick up. Then we can use constraint angle between this, where's that, between this straight edge, okay, and the x-axis of that datum coordinate system. So here you can define the angle between them. That way you can constrain the rotation of the wheel subassembly. Okay, now if you try to move this component, I think nothing will move. Okay, we just killed all the degree of freedom that time. Next, parallel, that's pretty easy, and you can try them out. Really, the concentric Okay, we can introduce concentric because it's kind of a little bit confused with a fit constraint. Okay, and let's see. First, we're gonna move this component down, and as you can see, we added a fit constraint for those two cylindrical faces, so they can align on the axial. Their axis will be aligned. However, what about the concentric? There are circles. You can use concentric also. So let's see what happens when we use concentric. Okay, so and notice here you cannot pick the surface, right? Remember, in fit we actually pick the cylindrical face instead of the edge or the whole body. So here I'm gonna pick the edge, which is a 2D geometry. Okay, whereas the cylindrical face is a 3D geometry, and we can pick this edge, or we can even pick the bigger one. Remember, in fit we have to pick the same diameter cylindrical faces. Now I'm picking different diameters. Okay, seems they are aligned in the center, right? However, if you move this subassembly, it cannot move on the axial direction. Why? Because concentric is a 2D constraint. Okay, whereas fit is 3D constraints. So what does that mean? If you put two circles concentric, they must be on the same plane. So let's take a look at the wireframe, or maybe a better way. Take a look at the cross section. So the that should do it. Remember, we picked this edge at the bottom of the body, right? And this outside edge of the bearing cup. So now they are coplanar. That's because concentric is a 2D constraint. It will put two circles in the same plane. So that's the difference between fit and concentric. Another difference is for concentric you can pick different diameters. For fit, it has to be the same diameter. So that's the difference. And next, fit, we have used that one for the dolly body. Okay, so for a whole assembly, you might want to put one at least, maybe also at most one part to be fixed, so your whole assembly will not fly freely in the space. So bound is basically you just make two parts not moving relative to each other. Okay? And we introduce the fit. So that's pretty much the constraint we need to talk about. Let's say, and there's one last constraint I need to talk about. That's center. Okay, this center constraint. We need to find a better geometry for this. Okay, let's move this away. So center, let's expand this. Okay, this is your subassembly, where the wheel, okay, is in the center of these two flanges, right? And how do we make it center? Of course, you can use distance constraint, which is here. You have distance. You can pick this face and the inner face of that flange, make them 0. So there will be, or you can use touch line to make it 0, and it should be touch each other. Or you can calculate the distance between them and make it the center of this U-shaped sheet metal. Well, there's a easier way is your center constraint. And let's go into this subassembly first. So make work part, and as you can see, the icon of your top assembly and other components are grayed out. So we are now in this subassembly, and you can see from the graphic. Okay, and if you expand here, we have this center constraint. Okay, I'm gonna delete this first, and you can move this component out. Note we have, let's display this. We have a fit constraint here, right? So that means you can't really move this X or Y direction. That's the radius direction. Okay, but you can move on the axial direction. So we want this to be the center of this U shape. We can use the constraint center, and here that's where the confusion comes in. You have 2 to 1, 1 to 2, or 2 to 2. What does that mean? Let's try 2 to 2 first. So that means two objects, the center of two objects is in the center of the other two objects. So in this case, we're gonna find the center of these two faces, which is in the middle of your wheel, right? You want this center to be coincident with these two faces. What will happen? It will put the center of this wheel to the center of your U shape. Okay, so now you know how to apply the center, this 2 to 2 subtype, and if you have only one thing, let's say if you have this y-axis or xy plane, let's try 1 to 2. Okay, so what is the 1? Is the 1 is there's nothing here. We can try here center. What's the 1? Let's find something. Maybe this axis. Okay, that's one axis. You want this to be okay, find the 1 first. That's the center line of your cylindrical face. We can put this center line to the middle of these two faces, and that's the same effect as we used 2 to 2, because you know the hole is centered on this U shape also. So there are really a lot of different types you can use, different options to achieve the same effect. Let's try to move this. Can't move this way, can't move that way. So essentially it's the same in terms of the results, but you can have different ways to make it. Alright, let's go back to the top assembly by just double click or right click and make work part. Okay, now we're operating within this top assembly, and we can put this back. Okay, put this subassembly back to where it should be. Okay, so that's all for the assembly constraints. And I guess we already introduced how to move a component. Some supplement is if you click, and by default is dynamic, which is this dynamic coordinate system at 6 degrees of freedom. You can try different method, like point to point, okay, delta x, y, z. It's pretty fun to use them, and just you're welcome to explore different options. And the next is sometimes you want to, like what we did for the subassembly, you want to modify a component within this top assembly, or sometimes you want to like make this hole bigger, change the geometry, etc. So what you can do is simply double click on a component, then now you're within this component, whether it's a model or a subassembly. Or you can double click on the top assembly to come back, or you can right click, make work part. That's the same effect. And in terms of if you double click on a part or model, now you can see that's a sketch coming up. And you go to your part navigator. Now basically you're like in modeling application, and you can change your sketch. You can change the parameters of this part. Okay, what if I don't want to see other components while I'm doing the modeling? Okay, let's go back to the top assembly first. Okay, so again, I'm gonna modify this part, but not within the assembly. I don't want to see other components. So I can do right click on this component, make displayed part. Okay, first let's go to window. So I have 3 windows open now, or 3 files open. The first 2 are the components, the assembly we made in previous semesters. So we can close them, make it clear, and let's go back. Okay, now I only have this assembly open, right? And I want to modify this part without seeing the other components. So we can choose make display part. And now we're back in the modeling, right? We can change the geometry of this part. And if you go to window, this part is loaded in an individual window. So that's the difference between make work part or make displayed part. Okay, and I think that's all for the assembly here. And in the next part, we will introduce the drafting application.